Hey, this is Steven from RC Engineering, and welcome to my Rule of Thumb YouTube video series. So, we're going to be going over some basic RC engineering principles for model cars, boats, and planes. So, for these first few videos, we are going to go over just some general stuff that you'll find on all three cars, boats, and planes. So, electricity, work, mechanical work, stuff that all of them will use. And then later on in the series, we'll start breaking out into individual stuff for individually for cars, individually for boats, individually for planes. So, because most of the models nowadays are electrically powered, I'm going to go over for my first video, what electricity is. So this is a article I found online. I really liked it, so we're going to go over it very quickly. So first, we're just going to go through it. Should be a very quick video talking about some different units and what they are, so you could understand electricity. First off, let's go ahead and get started. First off, electricity assumes that you have a closed loop instead of an open loop. Closed loop we call a circuit. So in order for a circuit to work, it has to be fully closed, as you see here. You can't have an opening there like that. So that's the assumption. So first, let's start off with the basic unit that originally that basically electricity is driven from, and it's called a charge. A charge is a very abstract term, abstract thought that is very hard to think of, that no one could really actually, because you can't really see a charge. You can't see, a positive and negative, charge. We just assume it's there from practice. Just like we can't actually see gravity, right? So we know that when we jump on Earth, we're reattracted back to Earth because of gravity, so we fall back to Earth, right? So, same thing with charges. When you have a positive charge, it's attracted to a negative charge, or these two are attracted to each other. And then when you have a negative charge, two negative charges, they're repulsed from each other. And when you have two positive charges, they're also repulsed from each other. So these are called forces. We have forces of attraction. These two are forces. These two are forces, and also these two are forces. So we have forces of attraction, which are basically when you jump in real life, gravity pulls you back down to Earth, right? And so you have a force going back down to Earth. What a lot of people actually don't know is that you're pulling gravity on Earth as well. The issue is that you're so small of a mass compared to Earth, the Earth doesn't even move, but you move quite a bit. So the force is actually on both objects. So same thing with gravity, the force is on you as well as on the Earth. Here it's on the positive as well as on the negative. The force is on both. And here are a few basic stuff. The charge is a unit known as a coulomb, abbreviated C. And these are very, very small positive and negative charges are generally very small. Charges generally come in lumps of 1.6 times 10 to the negative 19 C, which is about a tenth of a millionth of a trillionth of a coulomb. Which is extremely small. So 1 coulomb is extremely large. So let's go over what a coulomb is, and we'll learn more about this as we go through. And this is from Wikipedia here. Coulomb is the International Systems of Unit, SI unit, otherwise known as metric unit, of electrical charge. It is a charge transported by a constant current of 1 ampere 1 second, which is this. Thus, it also has 1 farad for 1 volt. But basically, we're not going to go really into this. Just think of it as it is the basis of electricity. It is two charges attracting to each other, right? A positive and a negative. Okay, so let's go over what we call those forces. So we have a positive charge and a negative charge attracting each other, and that force that are the attraction we call voltage. So down here, the voltage is the potential that separate opposite charges have for each other to fly together. It's called a voltage, and its unit is volts with uppercase V. The greater the voltage, the greater the force that is driving the charges together. Voltage is always measured between 2 points of reference. Yeah. So either the farther they are separated, or the bigger the charge of each, or both, the larger the voltage. And they always have to be measured between 2 points, a reference point. So for example, here at the positive side and here at the negative side. Same exact thing in a circuit. So let's go ahead and take a look at the voltage definition from Wikipedia. Volt is electrical unit of voltage or potential difference. 1 volt is defined as energy consumption of 1 joule per electric charge of 1 coulomb. So a joule, we'll learn right here, is basically energy per charge coulomb. And then 1 volt is also equal to the current of 1 amp times the resistance of 1 ohm, which is 1 volt is equal to 1 amp times 1 ohm resistance. This is known as Ohm's law, which we'll go over later. So let's take a look at this J. What is this J? The joule, symbol J, is a derived unit of energy in the metric system. It is equal to energy transferred to or work done on an object when a force of 1 Newton acts on that object, blah, blah, blah. We won't get into that. Basically what it is it is a measurement of energy. So for example, when I go into a room and my body's hot and the room is cold, I'm adding energy to the room. Also, when you have a circuit, for example, an LED light up because you have a battery attached to it, you're adding energy to that bulb, to that circuit, right? So we're not going to go into any of this right now. We're going to go into some of these that I posted, which are examples. And here, mainly where it came from, the heat required to raise the temperature of 1 gram of water by 0.24 degrees Celsius. And also the amount of electricity required to light a 1 watt LED or light emitting diode for 1 second. So that's how much energy it takes to light that light bulb, and that's 1 joule. So it is a standardized unit of energy, right? So 1 joule, so 1 piece of energy per charge, right? Which is basically the energy. What this means is the energy contained in 1 charge, right? So 1 volt is 1 joule of energy per coulomb. So it takes 1 coulomb to have 1 joule of energy, potential energy that can drive an LED, right? Or whatever. So now let's go into current. So current is basically, now that we have these 2 forces, which are known as a voltage, now what happens is, because they're separated, and let's say we don't have anything keeping them separated, they're going to attract to each other. And when they move, this is called current. So basically, the flow of charge is called electrical current. Current is measured in amperes, amps for short. An ampere is defined as a flow of coulomb of charge in 1 second. So an amp is equal to 1 coulomb per second. I thought I had what amps are, but oh yeah, right, this right there. We'll get back to it. So, and this is a flow from a positive side to a negative side. Current always flows in 1 direction. So let's say that we have, so here you see the positive here flowing this way to the negative. So let's say we had a 5 volt here and a 3 volt here. 5 volt is bigger than 3 volt, so this is the positive side and this is the negative side. So current is going to flow towards the negative side. Current always flows from the place of higher potential, or otherwise known as higher voltage, to the place of lower voltage. So let's say here we had 10 volt and here we had 6 volt. It's going to flow from the 10 volt to the 6 volt. Okay, so let's take a look at what an ampere definition is. Ampere or amp is a unit of electrical current. The ampere unit, don't worry about that. 1 ampere is defined as the current that flows with electrical charge of 1 coulomb per second. So how much charge is flowing from one side to another side? So if I have 1 coulomb move from one side to another side in 1 second, I have 1 amp. So for example, if I have 20 coulombs move from one side, from the positive side to the negative side in 1 second, that means I have 20 amps, right? So how much charge is moving how quickly, right? In real life, we have something called like speed, right? 1 mile per hour, right? And this, so it's the distance that it travels in 1 hour, right? But this one's the amount of charge. So how much charge is moving in 1 second, right? So now we're going to talk about what batteries are. So batteries, I'm going to go into just, I'm probably not going to go over anything that it says in here. Basically what a battery is imagine it as 2 plates, which most model planes and cars and boats now, they use batteries. So let's just say that we have, this is obviously a simplified version. So let's say we have 2 plates, and what's in here is we have chemicals, such as lipo or lithium ion or whatever, and we have positive and negative charge. So what happens is when we connect these with a wire, the positive rushes over to the negative. And what the battery does is it holds this charge while we don't have a connected circuit. So this is the battery, right? So we could actually carry that around and it will conserve that charge for us of positives and negatives stored on opposite sides. And then this piece in the middle keeps these two from attracting to each other. So there's a force, right? There's a voltage of these guys, they're being held separated from each other. The positive wants to go to the negative and the negative wants to go to the positive, but it does not allow the two to come to each other. They're separated, right? To where positive can't go to the negative, negative can't go to the positive. So what happens? When you attach a wire, when you plug it into your RC plane, car, or boat, and you plug it in, these guys are like, yay, I have a way of getting to the negative. So they're going to rush out and into the negative until there's no more positives left. So what do we do when we want to use it again? What happens is now we have the battery like this with positives and negatives, and now all the positives are gone and over here with the negatives. So now what we do is we plug it into a charger, which here's the charger, let's say, and the charger puts a voltage on it and will actually push it'll actually push the positives back over to their side, so you could run the cycle all over again. But we'll go into a video about batteries. That's just the basics. All right, so let's not go into the actual circuit stuff. And finally, the last piece is power. So what power is it's known as a watt, right? And what is a watt? 1 watt is known as joules per per second. And remember, joules is energy. So how much energy am I putting into something per second? So let's say you have a motor. How much energy from my battery that I have stored in my battery am I putting into the motor? So if I have higher energy that I'm putting into my motor, more power. Same thing as, you see on TV and stuff, lifting weights, right? The more weight I could lift, the faster I lift it. So let's say I'm going from the floor up to my chest. If I lift a higher weight in less time, then I have more power, right? So it's the amount of energy that you're putting into the circuit in a certain amount of time. So the more energy you put into the circuit, or the less time it takes for you to put that energy into the circuit, the more power you have. And it's known as a volt times an amp. So 1 volt times 1 amp equals 1 watt, right? So let's say you have a 10 watt electronic speed controller on your car or whatever, and you have a LiPo, 2-cell LiPo at 7.4 volt times 10 amps, that's equal to 74 watts. There you go. And here is how you get the power. Some different ways of getting it. So P power is equal to volt squared over the resistance of the circuit, which will go into resistance later, or P is equal to I squared R. And also it's known as heat. Heat's also energy or power. Yeah, so that's pretty much it. Here, let me go over this last term. In terms of electrical, okay, 1 watt is the rate at which work is done when 1 amp of current flows through an electrical potential difference of 1 volt. Alright, so that is the basics of this video, and this one, it might take you 2 times to go through it and pause every once in a while to make sure that you get it, but that is the basics of electricity. Don't worry about it. This is going to become we're going to use this a lot, so you're going to get more and more familiar with it. But I just wanted to get you guys accustomed with what electricity is, because it's used a lot and not a lot of people know where that stuff comes from. So when we go into looking at motors and stuff, and we're like, okay, this uses this voltage and this amperage and this power and this wattage, like, where is that coming from? This is where that is coming from. So we're going to go way deeper into this. This is just scratching the surface. We're also going to look at batteries. When we look at batteries, we're going to go a lot deeper into it. Alright, so that is pretty much it for this video. This has been Steven from RC Engineering, and I'd like to thank you guys for watching my very first video in the Rule of Thumb series. And please subscribe for more videos like it in this series and also on my main channel videos. And I will see you guys in the next video. Thanks for watching. Take it easy. Peace.